For an extended period, humanity has speculated about the potential for life in other universes. With the advent of the James Webb Space Telescope, currently the most sophisticated telescope ever built, the time may finally have arrived to address this question. While observing the closest star system to Earth, Proxima Centauri, located only 4 light-years away, scientists have noticed some unusual anomalies from one of the planets within the system, Proxima b. These anomalies, which have been dubbed artificial lights, have caused a stir among astronomers. But what exactly are these lights, and do they hint at the existence of intelligent life on the planet? Join us as we delve into the James Webb Space Telescope's potentially groundbreaking discovery of artificial city lights, an observation that could revolutionize our understanding of the cosmos. The search for life beyond Earth. At present, Earth remains the only planet we know of that supports life. From the earliest stages of human development, we have wondered whether life might exist elsewhere in the universe. To investigate this cosmic question, American space scientists Jill Tarter and Thomas Pearson launched the Search for Extraterrestrial Intelligence (SETI) program in 1984. The goal of this initiative was to capture spaceborne radio signals. Because radio waves can travel vast distances, they are more likely to be detected by the 42 radio telescopes that make up the Allen Telescope Array in the Sierra Nevada mountains of California. However, despite these efforts, no definitive extraterrestrial signal has been identified. With the successful launch of the James Webb Space Telescope, JWST, the mission now includes studying distant exoplanets orbiting faraway stars. As the largest telescope ever constructed, JWST is positioned about 1 million miles from Earth and equipped with highly sensitive instruments. Its potential for making groundbreaking discoveries is immense. Exoplanets and the search for biosignatures. Only a few decades ago, we had no knowledge of planets existing outside our solar system. Since then, more than 4,000 exoplanets have been discovered orbiting stars other than our Sun. As NASA has indicated, the universe could contain trillions of these planets. Early signs of life beyond our solar system might be found in extraterrestrial vegetation. The Galileo spacecraft, during its journey to Jupiter, turned its instruments toward Earth and identified clear signs of plant life by detecting what is known as the vegetation red edge. This biosignature involves a unique combination of red and infrared light reflected by plant matter. For instance, a planet like Earth, abundant in jungles, would exhibit a strong, easily identifiable red edge signal. The JWST is capable of measuring this red edge on distant planets that are Earth-like and situated in the habitable zone around their stars. This could provide valuable insights into the conditions present on these planets beneath their atmospheres. As light crosses through a planet's atmosphere, JWST may detect changes in the frequencies which can be identified using spectroscopy. As molecules and atoms in the atmosphere absorb specific frequency ranges, they create a unique fingerprint that JWST can analyze. This method allows scientists to determine a planet's atmospheric composition and assess its potential for supporting life. On Earth-sized planets, an atmosphere composed of oxygen, nitrogen, and carbon dioxide could be potential indicators of life. By looking for elements that are unusual, we could also detect the presence of intelligent life. For instance, chlorofluorocarbons, CFCs, chemicals commonly used in refrigeration and cleaning, could be detectable by extraterrestrials studying Earth's atmosphere from afar. If JWST identifies CFCs in a planet's atmosphere, it would be conclusive proof of technological advancement. However, life on exoplanets may differ drastically from life on Earth. Even typical Earth organisms, such as extremophiles, microorganisms that thrive in extreme conditions, could appear alien in nature. These species can survive in environments with temperatures up to 250 degrees Fahrenheit or in highly acidic conditions with pH levels below 3. Since Earth-like planets are more likely to support life than those with extreme temperatures or acidity, it may be wise to focus on those that present optimal conditions. These planets would likely have surface temperatures conducive to liquid water and orbit stable stars. Proxima b, a potential home for life. One of JWST's first missions will focus on the TRAPPIST-1 planetary system located about 40 light-years from Earth. It orbits a quiet red dwarf star and consists of 7 rocky planets similar in size to Earth. 3 of these planets lie within the so-called habitable zone, where liquid water could potentially exist on their surfaces. Despite the smaller size and cooler mass of the TRAPPIST-1 star compared to our Sun, it radiates light similar to that of Earth's Sunday. The close orbits of the planets around this star could make it an exciting target for study. Proxima Centauri, a red dwarf star located just 4.25 light-years away, also presents an intriguing possibility for detecting signs of intelligent life. In 2016, astronomers discovered a planet Proxima b with 1.3 times the mass of Earth located within the star's habitable zone, also known as the Goldilocks zone, where conditions are suitable for liquid water. Proxima b could be an airless dormant planet. Its close proximity to its star, only 4.6 million miles away, exposes it to intense solar winds, which could strip away its atmosphere. Despite this, Proxima b may still receive enough sunlight to allow for liquid water to exist on its surface. The planet is believed to be tidally locked, meaning one side always faces the star, much like the Moon does with Earth. Proxima Centauri is only 18% the mass of the Sun, and its light output is just 5% that of our Sun's. This suggests that Proxima b may appear barren and lifeless, but under the right conditions, such as an atmosphere capable of retaining heat, liquid water could still be possible. Despite its potential for harboring liquid water, the extreme conditions on Proxima b, such as high-energy radiation from solar flares, would make life challenging unless the planet has a protective magnetic field similar to Earth's. Could Proxima b harbor intelligent life? Researchers are eager to study Proxima b further, particularly through JWST, which may be able to detect artificial lighting on its night side. The detection of artificial city lights on Proxima b would be groundbreaking, indicating the possible existence of an advanced civilization. However, scientists remain cautious. The technology used by JWST is still evolving, and while artificial lights could be a sign of intelligent life, they might also result from natural phenomena. For instance, volcanic emissions, lightning storms, or unusual atmospheric events could cause signals that mimic artificial lighting. To confirm whether these lights are truly artificial, astronomers will need to continue their investigation and cross-check their findings. The future of space exploration. If the lights on Proxima b turn out to be artificial, it would mark one of the most significant discoveries in the history of science. The possibility of finding intelligent life on Proxima b or any other exoplanet raises profound philosophical questions about humanity's place in the universe. Such a discovery would emphasize the importance of space exploration and the need for continued investment in new technologies. The advancements needed to study distant worlds could in turn provide humanity with tools to better understand the cosmos. As JWST and future space missions continue pushing the boundaries of observation, it becomes increasingly clear that the universe holds more than we can imagine. The search for intelligent life represents a monumental leap forward for science, and each breakthrough brings us closer to answering one of the most fundamental questions: the implications of discovering intelligent life. If artificial lights on Proxima b are confirmed, the discovery would redefine humanity's place in the universe. Such evidence would indicate that intelligent life is not unique to Earth, raising profound scientific, philosophical, and ethical questions. One of the first concerns would be how to interpret and respond to this finding. If the lights are truly artificial, what might they reveal about the civilization that created them? Are they evidence of a thriving society, or could they be the remnants of a once advanced but now extinct species? Another major challenge would be establishing communication. At just 4.25 light-years away, Proxima b is one of the closest known exoplanets, but it is still an enormous distance by human standards. Any message sent from Earth at the speed of light would take over 4 years to reach Proxima b and another 4 years for a response to return. This delay poses significant obstacles to real-time communication. If Proxima b does host an intelligent civilization, its technological capabilities would be another critical question. Could its inhabitants be more advanced than us, potentially even monitoring Earth as we attempt to study them? Alternatively, could they be less developed, perhaps unaware of our existence? Beyond communication, the discovery would ignite debates on how humanity should proceed. Some scientists, like Stephen Hawking, have warned against actively reaching out to extraterrestrial civilizations, fearing that contact with an advanced species could put Earth at risk. Others argue that the benefits of interstellar communication, such as scientific exchange and potential cooperation, outweigh the risks. The future of space exploration and interstellar travel. If Proxima b does host life, even at a microbial level, the discovery would further justify expanding space exploration efforts. Governments and private space agencies such as NASA, ESA, SpaceX, and Blue Origin would likely accelerate their efforts to develop technologies for interstellar travel. Currently, traditional spacecraft using chemical propulsion would take thousands of years to reach Proxima b. However, emerging technologies such as light sail propulsion, which uses lasers to push a spacecraft at relativistic speeds, could reduce travel time to just a few decades. One of the most promising concepts is Breakthrough Starshot, an initiative aiming to develop nanospacecraft that could travel at 20% the speed of light, reaching Proxima B in about 20 years. If such a mission were launched within the next few decades, it could provide direct observations of the planet and its potential inhabitants. Preparing for first contact. If artificial lights on Proxima B are confirmed, how should humanity respond? Would we attempt to make contact, or should we remain silent and observe? The discovery of extraterrestrial intelligence would likely lead to global discussions involving scientists, policymakers, and world leaders. International organizations such as the United Nations Office for Outer Space Affairs, UNOOSA, would likely play a central role in establishing protocols for first contact. One of the most significant concerns would be ethical considerations. If Proxima B's civilization is less advanced than ours, how do we ensure that any interaction respects their development? Would it be ethical to interfere, or should we follow a non-interference policy similar to the Prime Directive from science fiction? Alternatively, if the civilization is more advanced, how do we ensure that our actions are not perceived as a threat? The potential for misunderstanding is immense, and any form of communication or interstellar diplomacy would need to be carefully planned. The search continues. Whether or not the lights on Proxima B turn out to be artificial, the search for extraterrestrial life is far from over. JWST and future telescopes such as the Nancy Grace Roman Space Telescope and LUVOIR, Large Ultraviolet Optical Infrared Surveyor, will continue scanning the universe for biosignatures and technosignatures, evidence of life and advanced civilizations. Each new discovery brings humanity one step closer to answering the age-old question: are we alone? If Proxima B does harbor intelligent life, it would mark one of the most transformative moments in human history, reshaping our understanding of life, the cosmos, and our own place in the universe.